Hey, what's up, kids? Happy April. I'm going to take you through a lesson today in applying properties of logs to expand. You don't know what that means yet. Condense expressions. We'll talk about what that means. And then also to apply the change of base formula in your calculator so you can calculate things that aren't of base 10 in your calculator. Here we go. Actually, we're going to start with change of base formula quick. So change of base formula, super easy. And here it is. It is that if you have the log base b of a, okay, like for instance the log base 3 of 14, and you want to figure out, okay, this means 3 to what power is equal to 14. There is no way really in your calculator, unless you have a special calculator, to do this by just changing the base to a 3 until now we have what's called the change of base formula, and here it is. The log base 3 of 14 is the same thing as, write this down with me, is the same thing as the log base 10 of 14 over the log base 10 of 3, which actually what's cool is that not only can we switch it to that, we could also do a natural log if we want to. It's the same as the natural log of 14 over the natural log of 3. So take a second and just plug this into your calculator. Log of 14 divided by, close that parentheses down, divided by log of 3. And what you're going to get is 2.04. It's the same as if you did natural log of 14 divided by natural log of 3. You're going to get 2.4 as well. So 2.40 is what that log's value is. So in general, the log base b of a is equal to the log of a, common log of a, over the common log of b. Okay, or the natural log of a over the natural log of b. Okay, you could do that as well. So it's cool. It's almost like a little bit of a loop. You loop around like this: log of a over log of b. Okay, so if we do, now you can use your calculator for the log base 12 rather of 9,165. Bingo. Common log of 9165 over common log of 12. Let's see what that is real quick. Log 9165 divided by log of 12. And you get 3.67, blah, blah, blah. Okay, awesome. So now you know it. Change of base formula. You can use it in your calculator. It's going to help us when we solve log equations here in a couple days. Now let's get to what this expanding and condensing expressions is all about. So we actually have three properties of logs that I want you to write down today. Starting with number 1, it's called the product property. As it turns out, if you had the log base b of m times n, so there was like a couple things as a product in inside what we're taking the log of, you can actually separate this out, and that would be the log base b of m plus the log base b of n. Okay, so write that down. Hit pause on the video, write it down, and then I want to show you why that's true. Watch this. If we had like the log base 2 of, let's say, 2 times 8. Let's do this for a minute. Okay, well, and we had that in parentheses. That's 16. What's the log base 2 of 16? That answer is 4. Okay, and watch this. We can actually separate this out. It says our product property. That's the log base 2 of 2 plus the log base 2 of 8. Okay, and let's make sure that works. What's the log base 2 of 2? That's 1. What's the log base 2 of 8? That's 3. 1 plus 3 is, voila, 4. So we have this product property that is true, and then we have the log base b of m times n. We can separate it out, all right? It's called expanding when we go from this to this. We can expand that into the log base b of m plus the log base b of n. Or if we had them separated out, we could actually do what's called condensing and move it back into the yellow. We'll talk more about that here in a minute, but if there's a product property that is also called something called a quotient property. And the quotient property, again, pause your video and write this down, says that the log base b of m over n is actually equal to the log base b of m minus the log base b of n. Okay, I'm going to show you how that works as well. I always like changing something generic into something specific so we can see how it works. So let's take the log base 2 of, let's keep using the numbers that I like here, 16 and 2. Okay, well 16 over 2 is 8. Okay, the log base 2 of 8, as we know, is 3. So what we just wrote down, that quotient property says what we're allowed to do is we're allowed to expand this into the log base 2 of 16 minus the log base 2 of 2. And let's make sure that's true. What's the log base 2 of 16? Whoa. Back that up. Smart board. 4. The log base 2 of 2 is 1, and 4 minus 1 is 3. Bang, bang. Okay, awesome. The quotient property is legal. Okay, and then the last thing is called the power property. This is different. This doesn't involve, two terms or two things we're multiplying or dividing, but rather when we take something to a power. It turns out that the log base b of m raised to the n power is the same thing as n times the log base b of m. All right, pause your video, make sure you have that written down. I want to show you how that works as well. Come here. So this is saying the log base 2 of, let's say, 4 to the third power. Okay, 4 to the third power. All right, that's what we're taking the log base 2 of. Well, that's the log base 2 of 64. The log base 2 of 64 is equal to 6, right? 2 to the 6th power is equal to 64. Okay, now, what the power property says we're allowed to do is we're allowed to take this 3 as a power, and we're allowed to move it out front and multiply it. It's the same thing as the log, or as 3 times the log base 2 of 4. And let's make sure that's legal. Okay, what's the log base 2 of 4? It's 2. 3 times 2 is 6. We get 6 both times. So the power property is also legal. And as I hinted in our product property, we have a condensed side here, and this green side is the expanded side. So if you go from yellow to green, you're expanding. Yellow to green, you're expanding. If you have a green expression and you move back this way to yellow, you are doing what's called condensing. And we're going to practice doing both today. So I'm going to show you that. Here we go. Let's practice. Let's start with expanding. Let's go to expanding. Okay, expand the expressions. All right, we have the log base 3 of 2 times x. All right, expansion. This is a product property. We can write that as the log base 3 of 2 plus the log base 3 of x. No problem. Okay, and then we're done. This is expanded. Okay, if this, let's say this turned out to be something nice, like what if that was the log base 3 of 3? Are we allowed to write that as 1? We could. If it was the log base 3 of 3 and you wanted to write that as a 1, I'd be way good with it. But otherwise, just using our expansion properties, you could leave it as well. Okay, we're just expanding that out into the sum of those two things. Okay, let's go to number 2 down below here, this vertical one. We're going vertically here. Okay, the log base 5 of w over a. This is still pretty simple. It's the log base 5 of w minus the log base 5 of a. And we're done. We've expanded it using our quotient property. Number 3, the natural log of y squared. Okay, this is, we could use our power rule to say that's 2 times the natural log of y expanded. Okay, let's go to some that have a couple steps going on in one. Okay, so the first thing is the natural log of 3x to the 4th. And what I want you to pay attention to is only the x is being raised to the 4th power. Otherwise, there would be a parentheses around the 3 and the x. But we're taking the natural log of this whole thing, and only the x is being raised to the 4th power. So the first thing I want to do is, since I see this product, is I want to separate the 3 and the x to the 4th. And I'm going to use my product property in order to expand that. Natural log of 3 plus natural log of x to the 4th. 4th. Okay, this one over here on the left is done. This one on the right, now I can use power property to take that 4 and bring it down out in front of the natural log. So I'm going to rewrite natural log of 3 plus, but now I'm going to say that's equal to 4 times the natural log of x. This is expanded fully. Okay. Number 5. Take a second here actually and take number 6 and move it down a little way so I got some space. All right, number 5. Last thing I'm going to do is I'm going to shrink this stuff down here so it doesn't get in our way. Okay, number 5's got quite a bit going on. We got a product, we have we have a fraction, so we know we're going to have a quotient. The first thing, my recommendation is if we have a fraction here, separate that fraction out. Okay, expand it using our quotient property, and here's how we're going to do that. This would be equal to the log base 6 of 7b squared minus the log base 6 of c. Okay, now this log base 6 of c, that's done, but over here, okay, we got still quite a bit of stuff to do here. This is the log base 6 of 7 plus the log base 6 of b squared. And then we have this minus the log base 6 of c that's just coming along for the ride. So we use product property to expand that out into a sum. And lastly, we're going to use power property on this log base 6 of b squared. So the log base 6 of 7, we're going to leave. And then instead of writing it as a log base 6 of b squared, it's equal to 2 times the log base 6 of b. And then this log base 6 of c, we're going to leave put. Okay, this is fully expanded. Notice I got rid of the fraction first by using our quotient property. Then I went ahead and separated our product, and then I did our power. Okay, number 6, I'm going to follow kind of the same principles. The log base 7 of 3x squared over 5y cubed. We have a fraction, separate that fraction out using our quotient property. So that would be the log base 7 of 3x squared minus the log base 7 of 5y cubed. What am I doing on time? Okay. So then I'm going to expand this, and then we'll get to the second one here in a second. All right. I'm going to separate. There's a product right there. That's a product. So I'm going to separate that out. That would be the log base 7 of 3 plus the log base 7 of x squared, which would be the log base 7 of 3 plus 2 times the log base 7 of x. Okay, expanding using power rule right there. And then minus, here's the deal. You're going to be subtracting, and so when we're going to end up separating this this product out, and we're going to have a plus sign to go with it, but we're going to want to keep everything in parentheses here, like, because we are subtracting, we're basically subtracting this whole thing right here. So whatever we do, however we expand that out, we're subtracting all of what's going in there. So what I mean by that is we're going to do the log base 7 of 5 plus the log base 7 of y cubed. If we did not have our parentheses here, watch what happens when I take my parentheses out here. Okay, if I take my parentheses out of here, now this log base 7 of y cubed actually has a plus sign as its sign, which means it's technically going to the numerator and actually going along with what was originally in the numerator, right? You could reorder these terms and bring this over here, and it was never in the numerator, it was in the denominator. So that's why we leave this parentheses around anything that was in the denominator. The other thing you could do is when you're all the way done, you could distribute the negative signs to everything that was in the denominator. I like leaving the parentheses there because it helps us. And the last thing we have to do with this is we have to expand because we have a power rule there. Okay, so I'm going to rewrite here the log base 7 of 3 plus 2 log base 7 of x minus, okay, in parentheses, log base 7 of 5 plus 3 log base 7 of y. Bingo. Okay. So putting everything that was in the denominator of our original expression in parentheses there is going to help us with our signs. Right? That's how expansion works. Okay, condensing is actually honestly simpler. We're going to do condensing and then our video is done. I know I'm running just a little bit long here, a couple more minutes. Okay, condensing is using the same properties but going from the right side to the left side when you originally wrote down your property. So if you have the log of x and the log of 5, you could condense that into the log of x times 5, which you'd probably just want to write as 5x. So that's the log of 5x. Okay, number 2, the log base 4 of 2 minus the log base 4 of w. Condensing, that would be the log base 4 of 2 over w. You might have looked at this right away and said, Mr. Hers, that's a half. You're exactly right, that is a half. Don't write that as a half because we are working on condensing expressions now, not necessarily evaluating. All right, number 3. This is expanded out 5 times the natural log of z. This is a product, or I'm sorry, a power property condensing that we're about to do. It's the natural log of z to the 5th. Okay, condensed. Okay, now let's go to number 4. We got a couple things going on here. The natural log of, or excuse me, the log base 5 of 7 plus 3 log base 5 of t. First thing I'm going to do is I'm going to use power property to condense that. So I'm going to say that's the log base 5 of 7 plus the log base 5 of t cubed. And then lastly, give me a second, give us some more room here. Lastly, I'm going to give us, I'm going to combine those by using our product property and condense them into the log base 5 of 7t cubed. It's always best to write a little parentheses around what we, I should have even probably done it here, what we're taking the log or natural log of. Okay. Lastly, or I'm sorry, not lastly, second to lastly, number 5, we're condensing natural log of 4 plus 3 natural log of 3 minus natural log of 12. So only numbers here, but you can still do it. Okay, this is the natural log of 4 plus the natural log of 3 cubed minus natural log of 12. Okay, this is the natural log of 4. I'm actually going to erase this and call it 27 right away. Okay, the natural log, because 3 cubed is definitely 27. This is the natural log of 4 times 27 minus the natural log of 12. Okay, 4 times 27 4 times 27 is 108. So this is the natural log of 108 minus natural log of 12. Okay, and last step, this subtraction means we could condense into the quotient of the natural log of 108 divided by 12, which is actually just equal to the natural log of 9. Pretty crazy how something that was somewhat complex to start with, just became the natural log of 9 when we used our condensing rules. Okay. Lastly, number 6, the natural log of 18, 2 times the natural log of 18 minus 2 times the natural log of 3. There's actually 2 things you could do here. You could distribute this too, okay, or you could condense this and then use our what's going to end up being our power rule here. So I'm going to actually condense what's in parentheses first, and then I'll worry about that too. So this is 2 times the natural log of 18 over 3, which is 2 times the natural log of 6, which then to condense, I could bring that 2 up as a power, which is the natural log of 36. Okay, bingo. Plus 2 times the natural log of x. That kind of just came along for the ride. I hadn't messed with that yet. So I'm going to say that's the natural log of 36 plus the natural log of x squared. And lastly, I'm going to use product property to combine those and say that's the natural log of 36x squared. Boom. Okay. Went through quite a few examples. I went kind of quick, but it's a video. Miss you guys. Hope that was helpful. Have a great day.